welcome to the next session of the alkaline earth metals multiple choice questions. So for today we are going to observe different multiple choice with respect to alkaline earth metals, and we'll see how it is going to be beneficial for us. So let's start with the first question. So question number 1. Which of the following is called as barytes? Okay, so in our theory section, that is the important points for the NEET and JE exams, we had discussed about the important ores. Okay, so one of the important ore of barium is barytes. Okay, so barite is actually barium sulphate. Okay, so barium sulphate is nothing more than barite. In India, there is a single largest deposit, and that is in Mangalam Pit. Okay, so this Mangalam Pit is situated in Kudappa district. Okay, Kudappa district of Andhra Pradesh, wherein we find a very single large deposit of barium sulphate, the largest in the world. Okay, so barium sulphate is nothing more than barite. Let's observe the names of the other ones. So when we are looking at BaCl2.2H2O, barium chloride, dihydrate, because there are two water molecules, we call it as a dihydrate. Barium oxide. Next one is barium carbonate. Okay, so answer actually over here is 1, that is barium sulphate. Let's observe the next question. So the second question, the low solubility of barium sulphate in water can be attributed to. So when we are taking a look into barium sulphate, or for that particular matter, any of the crystalline compound which is formed, it all depends upon when it is forming the crystal, how much amount of energy it is liberating. Higher the energy that is liberating while forming the crystal, the greater is the lattice enthalpy. Now enthalpy is nothing more than energy, right? So greater the amount of energy that is going to be liberated once this particular crystal is formed, higher is the crystal stability. So in the case of barium sulphate, what we see is it has a very high crystal lattice enthalpy. That means it is liberating a lot of energy while forming the crystal lattice. On the other hand, when we observe the second point for it, it has low hydration enthalpy. Due to this particular factor, what happens is it is going to be having low solubility. Okay, so among these two, what we have here is one of the answer, and that is A, as high lattice enthalpy. Okay, if we had another option, we could have gone with that also, but they have discussed nothing about the hydration enthalpy. So we would like to go with high lattice enthalpy, that is option A. Okay, so why it is less soluble is because it has a higher lattice enthalpy. Let's observe the next one. Let's observe question number 3. In which of the following hydration energy is higher than the lattice energy? So in this case, they have started with barium, magnesium, radium and strontium sulfates. Okay, so whenever we take a look into the series as beryllium, magnesium, calcium, strontium and barium. Okay, as we travel down a particular group in this particular case, what do we observe is, as we go down, the ionic character. character goes on increasing. Okay, it goes on increasing for these particular sulfates. No doubt it's correct. Now, as this particular ionic character goes on increasing, that means the sizes of the ion also goes on increasing. As the sizes goes on increasing, can we say that beryllium sulfate is smaller one? Okay, followed by magnesium sulfate, followed by calcium sulfate, and what we have is strontium sulfate, finally the barium sulfate. So can we say that the size of barium is quite large, that is Ba plus 2 is quite larger than Be plus 2, right? So greater the size, lower is the hydration enthalpy. Okay, so remember this particular fact. Greater the size of ion, smaller is the hydration enthalpy. Okay, so taking that particular consideration, we can say that this thing has a lower hydration enthalpy. Okay, radium again very less. Okay, barium less according to this entire series. So what remains with us is magnesium sulfate. Okay, we have already discussed in the previous question about this barium sulfate. What we have seen is over there, it has a very high lattice energy. Okay, but it has low hydration energy or enthalpy, can say. Okay, while magnesium sulfate, because of the smaller size of magnesium, it has high hydration enthalpy or hydration energy, can say. Okay, while it has low lattice enthalpy. Okay, so this is how it forms. Let's observe the next one. Let's observe the next question. Question number 4. Which of the following is a true peroxide? Now, let's discuss about the first one. So here, when we take a look into option B, let's speak with option B. Okay, Mn. So Mn is connected to oxygens somewhat like this. Okay, so MnO2. This is not a peroxide. While because only one is connected to the two oxygen here. So it's not a peroxide. Peroxide refers to one particular atom connected to one oxygen. Okay, so that is how it should go. Now, therefore, this is not a correct answer. While SO2, again, SO2, which has actually a bent structure, we can represent it like this. Again, it's not a peroxide. NO2, again here, NO2. Okay, again, not a peroxide. Now here, when we observe about barium, Ba, okay, is connected to O2 as O2 minus 2 charge. So here, the barium is connected to only one oxygen. Of course, it has two oxygen in the entire compound, but it is connected to only one oxygen, and therefore we consider this as a peroxide. Okay. So, let's observe the next question. The decreasing order of ionization potential for alkaline earth metal is. Now, here they are asking about the ionization potential. What is ionization potential? We already know about that. We have already spoken about that in the periodic table, right? In periodicity, we have already completed those all things. So, ionization or ionization potential is nothing more than how much amount of energy is required in order to remove an electron from the outermost shell, right? So the amount of energy that is required in order to remove an electron from the outermost shell of an atom which is in gaseous state. Now here, of course, this entire thing is taken in gaseous state, but we need to observe with respect to alkaline earth metals. So simple phenomenon, simple way is remember the series. Okay, so what we have, the smallest one is barium, followed by magnesium, followed by calcium, then strontium, right? This is how it goes. And finally what we have is of course the barium. Here in this case they have neglected barium. Fine. We will take only this particular thing into consideration. Okay, so now what will happen? Magnesium, calcium, strontium, barium. This is a series. So can we say that this is smaller? Comparatively larger is this one. Comparatively very large is this. And finally the largest one is going to be this one. Okay, so as the size of atom goes on increasing, that means the distance from the nucleus to the outermost shell, it increases. As this particular distance increases, the electron, the outermost electron, is not bonded so comfortably, so strongly with the nucleus. As a result of which, a small amount of energy would be enough to take off the outermost electron from the outermost shell of an atom in its gaseous state. So therefore, what is going to happen here is, as we come down the particular group, the energy required in order to remove electron from the outermost shell decreases. So therefore, highest energy is taken by magnesium, lower than that is going to be taken by calcium, lower than that by strontium, lower than that by barium. So this is the sequence. So if we observe, magnesium and barium should be on the extreme corners. So we have only one option like that over here, and so therefore the option A is the correct one. Okay, let's observe the next question. Question number 6. One of the most important questions that we have to discuss for today, and that is this: which pair of substances will give the same gaseous product when these react with water? So you need to know the reaction of these particular elements with water. Okay, so let's start. First one, let's start taking sodium into consideration, because that is going to be the easiest one for you people to understand. Okay, so let's start with sodium. So when we take into consideration of sodium, sodium is going to react with water in order to produce, what it produces is sodium hydroxide. Okay, plus it eliminates hydrogen. Okay, in order to balance it, let's take over here 2. So if I am taking here as 2, that means there should be 4 hydrogens. So here 2. So this would balance the entire equation, right? So first one, we have seen that this is giving hydrogen. Fine, byproduct is hydrogen. Now, next one what we have is Na2O2. This is again peroxide. So Na2O2 plus H2O would give us 2NaOH. Okay, byproduct now is going to be very important, H2O2, that is hydrogen peroxide. Okay, so let's observe if it is balanced. So the number of hydrogens what we have here is 2 plus 2 should be 4. So we are going to take over here as 2. Okay, as we take over here as 2, so 2 oxygens over here, 2 oxygens, 4 oxygens completely. So 2 oxygens, 2 oxygens, 2 sodium, 2 sodium. Now, if I observe it carefully, this sodium is giving me a byproduct as hydrogen. Sodium peroxide is giving me a byproduct as hydrogen peroxide. So this is not the option for answers. Okay, so let's see about the potassium and potassium hydroxide. So when we take into consideration of potassium, react this potassium with water, it will give rise to potassium hydroxide. Along with potassium hydroxide, of course, hydrogen is going to be eliminated. Okay, so in order to balance this entire synthetic. Let's take over here as 2. 2 over here, 2 potassium hydroxides. So 2 into 2 is 4 hydrogens. 2 hydrogens plus 2 hydrogens, 4 hydrogens on the product side. Perfectly balanced. 2 potassiums, 2 potassiums, 2 oxygens, 2 oxygens. Perfectly balanced. Okay, let's observe with respect to KO2. Okay, so peroxide. So now we'll take over here water. So when we take water again, it will give rise to potassium hydroxide, and the byproduct again it is giving me is hydrogen peroxide. So now, in order to balance it, let's see. How many hydrogens do we have? 2 over here, 1 over here, 3. So in order to balance it, we'll make it 4. So 2 over here. Now, what we have is 2. So 2 over here. 2 potassiums, 2 potassiums. 2 oxygens plus 2 oxygens should be 4. 2 oxygens and 2 oxygens, 4 oxygens. Perfectly balanced. 2 hydrogens, 2 hydrogens. So here, 4. Right? So 2 plus 2, 4 hydrogens. Again, perfectly balanced. But what we see, potassium on reaction with water giving hydrogen, gives a gaseous byproduct as hydrogen, while potassium superoxide is giving us hydrogen peroxide. So therefore again, this answer is not correct. Let's observe next one. That is barium. So barium on reaction with water gives rise to barium hydroxide. Okay, so along with the barium hydroxide, it gives hydrogen over here. Okay, in order to balance it, let's take over here as 2. So 2 oxygens, 2 oxygens. So we have here 2 hydrogens here, 2 hydrogens here, 4 hydrogens, 4 hydrogens, perfectly balanced. Let's observe about BaO2 plus H2O. So here, it will give rise to BaOH again twice plus H2O2 again hydrogen peroxide. In all these particular cases we have hydrogen peroxides. Okay, now 2 hydrogens here, 2 hydrogens here, 4 hydrogens, and in order to balance it we have 2 here, so 4. Okay, 2 oxygens plus 2 oxygens, 4 oxygens, so 2 oxygens, 2 oxygens, 4 oxygens, perfectly balanced. So neither is this particular thing as an answer. What remains now is the calcium and calcium hydride. Okay, so calcium, once it is reacted with water, it will give rise to calcium hydroxide plus hydrogen. In order to balance it, let's take over here as 2. 2 oxygens, 4 hydrogens, 2 plus 2, 4 hydrogens. Perfect. Okay, so it is giving rise to hydrogen here. Let's observe about calcium hydrate. CaH2 plus H2O. It will give rise to. Let's check. So CaOH twice plus what remains with us? Let's check. So in order to balance it, we'll take here as 2 because we have 2 oxygens here. Now there are 2 oxygens here. Okay, so 2 plus 4 hydrogens. 6 hydrogens, 2 plus 4 hydrogens. So 6 hydrogens. So in this case, if we see the byproduct, that is the hydrogen, which is correct one. Correct? Both of them are giving rise to hydrogen. So answer is A in this particular case. Alright, so let's observe the next question. Question number 7. The most basic among these hydroxide is, okay, so in order to answer this, first we'll take down the entire series, that is beryllium, magnesium, calcium, strontium and barium, right? So when we observe about barium, that is beryllium oxide and beryllium hydroxide. Okay, so these things are actually It is amphoteric in nature. It reacts with acids as well as it reacts with a base. While when we check about magnesium, it's oxide and hydroxide. What we observe is these are actually weak bases. These are very weak. Okay. While calcium, strontium, barium, these things forms the oxides and the hydroxides, which are actually very strong bases. Okay, now one thing that we have to understand is these hydroxides or oxides, as we come down a particular column, a particular group, what happens there is this solubility goes on, what happens? Goes on increasing. Okay, so solubility goes on increasing as we come from the beryllium to barium. Okay, so now that means beryllium hydroxide, okay, is weaker base compared to that of magnesium hydroxide, compared to that of what we have is calcium hydroxide, compared to that of strontium hydroxide, and finally as what we have is barium hydroxide. Okay, so now as we come down a particular group, size goes on increasing. The tendency to liberate OH minus ions goes on increasing. The particular substance which donates OH minus is nothing more than a base. The greater the tendency to donate OH minus is a stronger one. Okay, if it is giving me OH minus much more easily, then that particular substance we consider it to be as a stronger base. Okay, and that is true in this particular case. That means this is the weakest one, this is the strongest one, and so therefore our answer will go with respect to C, that is barium hydroxide. Okay, so answer over here is barium hydroxide, which is actually more basic among these all hydroxides. Okay, so let's observe the next question now. Forward with question number 8. A metal M readily forms sulphate MSO4, which is water soluble. Okay, so it is having water soluble sulphate. All right, so first trick over here is MSO4 is water soluble. Okay, so in such kind of cases we need to understand what are the solubilities, okay, which particular substances are soluble. So it all depends upon these elements. Okay, keep in mind about the series as we solve about this. So M forms metal sulphate, which is water soluble, fine. It forms it forms an oxide MO, which becomes inert on heating it and forms insoluble, okay, insoluble hydroxide. Our second hint is this. Okay, so it is forming insoluble hydroxide. Insoluble hydroxide. So we have already spoken about the entire series. Okay, so BeOH, weaker base. Okay, as we come down, it is going to be more soluble. Okay, remember that. So it is forming insoluble hydroxide, that is MOH twice, which is soluble in NaOH solution. Okay, now in order to go for this question, you should remember about this hint, that is insoluble hydroxide. If we observe the entire series, the first element, that is BeOH, which was amphoteric, it reacts with acid, it reacts with base. When it is reacting with base, that time only it is going to get soluble, right? So therefore, what we have is actually it is Be. Okay, How did I come to this conclusion is because of insoluble hydroxide. Solubility is very less for beryllium hydroxide. We had discussed about the entire series before. Okay, so beryllium, once it is reacted, it is forming beryllium sulphate. This beryllium sulphate, further on reaction, it is forming beryllium oxide, which is inert in nature. This, upon reacting with water, it is forming BeOH twice, and finally you are trying to react this one with sodium, right? So upon reacting with sodium, we get Na2BeO2. This one we call it as sodium berylate. Okay, so sodium berylate is formed from beryllium. So our answer is D, beryllium. Forward with question number 9, and that is a certain metal M is used to prepare antacid. Okay, this metal accidentally catches fire, which cannot be put out by using carbon dioxide based extinguishers. So now the metal M is okay. So here you should know that antacids are nothing more than the substance which neutralizes the reaction in stomach. Okay, so for that, of course, we take into consideration of sodium antacids are there, calcium antacids are there, magnesium antacids are there. Okay, but the answer is of course not all of this. Okay, so now, of course, sodium reacts with air. Okay, it reacts violently in atmosphere. Okay, because of the presence of moisture, it reacts violently. Not a problem. But once this catches fire, we can use carbon dioxide based extinguishers in order to put off that particular flame. Because carbon dioxide reacts over there in order to form sodium carbonates. It can happen. But with respect to calcium, also the same reaction happens. But when we observe about magnesium, what happens here is magnesium, okay, reacts very violently with carbon dioxide. Now let's assume that we have the metal that is magnesium. While preparing an antacid, it has caught fire. It catches fire. Now, when I take any carbon dioxide based extinguisher and I try to spray on that time what is happening is the remaining magnesium metal is reacting with whatever carbon dioxide based extinguisher we are spraying on that. The moment it comes in contact with this, a violent exothermic reaction occurs. That means it gives out a lot of amount of heat, and that time it will produce magnesium oxide giving out carbon. Now in order to balance this, let's take over here as 2. So 2 magnesium plus carbon. So this reaction is going to be quite very explosive or exothermic in nature. Okay, so the answer is magnesium, right? So the next question number 10. Among these, that is potassium, calcium, ferrous and zinc, the element which can form more than one binary compound with chlorine is, okay. So let's observe potassium. Potassium, as we know, the oxidation state of potassium is +1. Therefore, K plus, okay, it can attach with only one chloride, Cl minus potassium chloride. Okay, it cannot form second binary compound with this. Okay, so only one compound that is possible by potassium, and that is potassium chloride. When we observe calcium, calcium exhibits only one oxidation state, and that is +2. Therefore, it forms CaCl2. Okay, so is the same case with zinc. Zinc +2 state, therefore zinc chloride. Now what remains is Fe. So Fe can exhibit two oxidation states which are stable. One, we call it as +2 state. Okay, if it is combining, if the chlorine is combining with this particular ferrous in +2 state, we get FeCl2, which we call it as ferrous chloride. Okay, while it also exhibits +3 state, wherein we get compound FeCl3, which we call it as ferric chloride. So we have two different things, ferrous, ferric. Okay, so the answer over here is D, that is Fe, right? So let's observe the next one. Which pair of the following chlorides do not impart color to the flame? So the color to the flame is not because of chlorinization. No, it is not because of the chlorine. It's all because of the metal association. We have already spoken about the different alkaline earth metals. When we take this particular source and when we put it into flame, it has a tendency to give us different types of colors. Okay, so therefore, taking that into consideration, observe that smaller the size of atom, the outermost electrons are firmly bounded with nucleus. So smaller sizes are the ones which are not going to give us any color to the flame. We have already discussed about this, and therefore, taking this into consideration, beryllium, magnesium, calcium, strontium, and of course barium. Okay, so as we go down this particular group, size is going to increase. Okay, so what we have is these two things which are having smaller size. As these two have very smaller size, the electron is bonded more firmly to the nucleus. Therefore, the energy from flame is not quite sufficient in order to excite this electron. It cannot excite the electron. As the electron cannot get excited, it cannot reach the higher orbital level. As it cannot reach the higher orbit, no de-excitations. As there are no de-excitation, there is no flame color change. So therefore, it is not going to impart any color to the flame. And therefore, I need to search a particular combination of these both. So therefore, there is only one combination, and that is D. That is beryllium chloride and magnesium chloride. Okay, so let's observe the next one. So question number 12. Again, it all depends upon the series, even in this particular case. So the second ionization enthalpy for which of the following alkaline earth metal is highest? So again, taking into consideration of the series. So if you know the series, it's quite very useful. Smallest one, beryllium. Then comes magnesium, calcium, strontium, barium. Okay, so as we go from beryllium to barium, size goes on increasing. Now they are asking about the second ionization energy. So it is going to be common for second ionization energy for beryllium, second for magnesium, second for barium, second for calcium. All those are elements which are going to have the same second ionization enthalpies. But sizes are going to vary. That means the size of beryllium is quite smaller. So when you are trying to remove the second electron is going to be much more firmly bonded to the nucleus than compared to the second ionization energy for removing the second electron from magnesium, because the size is comparatively bigger. When we take a look into the calcium, again the size is going to be much more larger. Strontium, again larger. Of course, barium is going to be the largest in the entire group there. Okay, so therefore, what is going to happen is, for the barium, what we see is, it is going to exhibit the highest ionization enthalpy. because of its smaller size. And therefore, the answer over here is A, beryllium. Okay, let's observe the next one. The next question again. The lightest metal is. Now, they have mixed two series together. Alkaline earth metals and alkali metals. Right? So they have mixed over here alkali metals along with alkaline earth metals. So we have already discussed about lithium being the lightest metal. Okay, so therefore answer is A, that is lithium. Okay, so now let's observe the next question. Number 14. The dark red color of the bombs in a firework is due to the presence of. Now here is where you require firm knowledge of which element produces what kind of color. Okay, so therefore when we observe about sodium, it gives us golden yellow, right? Barium, what we have is apple green, and strontium here we have a crimson red color. So our answer is with respect to strontium. Okay, so strontium based salts are used in the fireworks, which are capable of producing different colors. Okay, coming towards the next question, question number 15, one of the most important questions again. So here, which is used to produce smoke screen. Okay, so first thing, what exactly is smoke screen? Smoke screen is nothing more than a cloud of smoke which is usually generated by the reactions of chemicals in military operations. Okay, so here usually they take calcium phosphide, and this particular thing reacts with water. Upon reacting with water, it gives rise to calcium hydroxide. Along with this, we get pH3, and that is phosphine. Okay, so this one is phosphine. So, in order to balance it, let's take over here as 6. Okay, so 3 into 2, that is 6 oxygens. So 6 oxygens here, perfectly balanced. Okay, so now this phosphine, what is generated because of the reaction between calcium phosphide and water, okay, that thing again undergoes further reaction. That means it is liberated in open air, in open atmosphere. In the atmosphere, it will start reacting with oxygen. The moment it starts reacting with oxygen, it forms phosphorus pentoxide. Along with this, we get water molecule. Okay, so in order to balance it, let's take over here 4 oxygens. So 4 into 2 is 8. So 3. So 3 oxygens plus 5, 8 oxygens. Now, this thing, what is being produced is actually one which is dense white fumes. So, that is nothing more than the smoke screen. Okay, usually it is used in the form of granites. The moment they throw it, that particular reaction is a reaction between calcium phosphide and water, which releases poisonous gas phosphine. This poisonous gas phosphine reacts with oxygen in air, okay, liberating a lot of dense white fumes. It covers the entire area, okay, and therefore that itself is called as smoke screen, which is used in military operations. Question number 16. Philosopher's coal, when heated with PaO at 1100 degrees Celsius, gives a compound identify the compound. Okay, first thing we need to understand is what exactly is this philosopher's wool. Okay, so philosopher's wool is zinc oxide. Okay, so this zinc oxide, they are asking us how it does react with barium oxide. Okay, so when this thing reacts with barium oxide at 1100 degrees Celsius, we get BaZnO2, which is called as barium zincate. Okay, so barium zincate, and that is nothing more than the option 1 here, which is actually the correct one. Okay, question number 17. The compounds of alkaline earth metal have the following magnetic property. Now, observe here, they have given us the alkaline earth metals. Okay, so when we observe about the alkaline earth metals electronic configuration, so that electronic configuration as what we have is having over here electronic configuration of noble gases followed by ns2. Now, what do we know about s orbital? S orbital has a tendency to accommodate 2 electrons. So, as s orbital can accommodate 2 electrons only, because of which what is going to happen is these electrons are going to be in a paired condition. This is what is called as a paired conditions. Okay, so as this electrons are present in s orbital, last electrons, valence electrons are present in s orbitals, and these s orbitals are paired. When it is paired, it is not going to exhibit any magnetic characters. Okay, if it is unpaired, of course, it will reflect under the presence of an external magnetic field. It will show you certain deflections. But now, because of its paired condition, it is not going to exhibit any of such things in a magnetic field, and therefore we have a diamagnetic conditions for these particular elements. Okay, so 17th answer is D in this case. Now observe question number 18. Which of the following metal will give us hydrogen gas on reaction with sodium hydroxide? Okay, so now let's observe the reaction. Zinc, as they have given us the first option, zinc reacts with sodium hydroxide in order to form Na2ZnO2. Okay, now this one is called as sodium zincate. In order to balance it, let's take OH2 plus what happens here is the liberation of hydrogen. Okay, so 2 oxygen, 2 sodium, 1 zinc here, 2 hydrogens, 2 hydrogens. So therefore, the first element itself is going to give us hydrogen on reaction with any OH. Okay. Moving towards the next question, and that is question number 19. Which of the following metal is found in green coloring pigment of chlorophyll of plant? Okay, so here it's actually the magnesium. It's a conceptual answer. Okay, knowledge based question. It is the magnesium which is formed in the pigment of chlorophylls. Okay, so let's observe the next question. So a mixture of MgCl2 and MgO. We have already spoken about this, that when we take MgO, magnesium oxide, and treat this one with saturated solution of okay, this entire thing will start getting harder, right? As the time progresses, in 5 to 15 minutes, this entire solution will start getting harder. It just appears as cement, and due to which it has a name as Sorrells cement. Okay, so it is called as a Sorrells cement or magnesia. Okay, this is what we have already seen. So therefore, the answer is B in this case. That is Sorrells cement. Question, and that is the alloy of dash metal are light and strong, and so they are used in manufacture of aeroplane parts. So we have already spoken about this. That is, magnesium is used in preparation of alloys which are actually very, very light and strong. Okay, and hence they are used in the aeroplane parts, in manufacture of aeroplane parts, and we have already discussed about this. Let's observe the next question. Among these, take the odd one out. So, potash, alum. Now, whenever we are coming across such kind of things, it is advisable for you people to write down the formulas, because it is going to be very helpful in future. Okay, so let's observe the first one, that is the potash, alum. Have potash here, SO4 2 times dot 12 H2O, and this is the chemical formula for potash alum. So potassium aluminium sulphate dot 12 H2O. Observe the next one is carbonylite. So carbonylite KCl MgCl2 dot 12 H2O. Okay, next one is FAS, ferrous ammonium sulphate. So NH4 twice Fe SO4 2 times dot H2O. Okay, so this is FAS. So now, when we have this entire thing, observe that in this, all of this, there are two metals, okay, and one metal over here, and this is ammonia in consideration. So these all are double salts. Okay, so there are two types of conditions, or two salts mixing up. So these, all of them are actually the double salts. While if we observe ammonium sulphate, NH4 twice SO4. Okay, so ammonium sulphate is not as what we have a double salt in this particular cases. Therefore, the odd one in this entire scenario is the ammonium sulphate. Okay. Coming forward, which of the following is fluorospar? Fluorospar is again a very, very important compound, which is CaF2, calcium fluoride. Okay, so answer is A in this particular case. Next one is CaO, calcium oxide, HF, hydrogen fluoride, CaCO3 is calcium carbonate. Correct? So those are not fluorospar. Fluorospar is calcium fluoride. Let's observe the next one. So the next question is, bone ash contains, now bone ash contains calcium and phosphorus elements. Okay, so we need to observe that there are two conditions: calcium phosphate, calcium hydrogen phosphate. Okay, so bone ash is actually Ca3 PO4 2 times. So this one is nothing more than calcium phosphate. Okay, so calcium phosphate is Potash. Let's observe the next question. Question number 25. The metal oxide of the second group element, which is used in decarboxylation agent. Now, decarboxylation, once you start studying organic chemistry, you'll come across various of such reactions wherein we are going to remove certain groups from the reaction system. Whenever we are removing the group, depending upon which group it is, if we are removing halogen, we call it as a dehalogenation reaction. If we are removing hydrogen, dehydration reactions. Okay, if we are going to remove carboxylic group, we call it as a decarboxylation. So for those particular reactions, usually we use calcium oxide. So the element oxide from the second group element used in decarboxylating agent is calcium oxide. So I hope you have understood all the concepts for today. Take care and have a great day.